When you're solving problems or equations, one thing you need to be thinking about constantly is the number of solutions that might exist. Often we think there's one solution, but in some cases there may be no solutions, in other cases there may be many solutions. So I want to talk about this number of solutions issue with respect to quadratic equations. And we know from our study of quadratic equations that the solutions to an equation correspond to the x-intercepts or zeros of the corresponding function. And I have an example of that here just to remind us. We have a quadratic equation. It's in one variable and we've got it set to 0. There's many ways we can solve this equation, one of which would be factoring. So I'll use that since it's quick. We factor our equation and we come up with our solutions. In this case, there are two solutions, which there often are for quadratic equations. And in terms of the connection to the corresponding function in this case would be our quadratic equaling y, which is made up of an infinite number of points. But the connection of these solutions to the equation and the function are that the x-intercepts of the function are the solutions to our equation. And we know our quadratic function is a parabola, in this case opening up, and there's our two solutions visually. Over on Desmos, I have a general quadratic function set up here, ax squared plus bx plus c, and I have the coefficients for a, b, and c set to match the example I just calculated. And you can see the x-intercepts at -1 and -3. But as we know, there's not always two solutions to a quadratic equation. A different equation might produce one solution, it might produce no solutions. So what I'm going to do here is I'm just going to change the coefficients for a, b, and c. And you'll notice that as I do that, my function changes, and I can get situations where there are no x-intercepts, which would correspond to no solutions on the equation. Or if I get this really carefully, I can maybe get the parabola just sitting on the x-axis, in which case I have one solution. So the values of a, b, and c in the general form of a quadratic equation will determine the number of solutions. So we want to look at, is there a quick way we can decide or figure out whether a quadratic equation has 0, 1, or 2 solutions without doing a lot of work? And so for that, we're going to look a little bit more closely at the quadratic formula. We know that the quadratic formula can be used to solve any quadratic equation. And specifically, the part of the quadratic formula under the square root sign, the b squared minus 4ac, this is called the discriminant, which I'm going to abbreviate capital D. And the discriminant can help us in determining the number of solutions that a quadratic equation has. And here's how that would work. If we had a quadratic formula set up as -b plus or minus the square root of, if this was a negative number under here, we would know that since we can't square root a negative number, there would be no solutions if the discriminant, the number under the sign, was negative. If we had our quadratic formula set up and we ended up with a 0 under the square root sign, a discriminant of 0, we would know that there would be one solution because we would have -b plus 0 and -b minus 0, which would be the same solution. So we would have one solution if the discriminant was 0. And then if we had a quadratic formula where we had a positive number under the square root sign, a positive discriminant in other words, we would have -b plus or minus the square root of a number and -b minus the square root of a number, which would be two different numbers, which would be telling us that we have two solutions if the discriminant is positive. So let's try this out with this example. We'd like to know the number of solutions to this quadratic equation. And to decide that, we know that we can look at the discriminant, the portion of the quadratic formula under the square root sign, to decide how many solutions there would be. So from our quadratic equation, we know that a is 1, b is 2, and c is 3. And if we plug those numbers in to our discriminant, we can see that our discriminant is coming out to -8, which would mean that in our quadratic formula we would have a negative number under the square root sign, which we can't calculate. Therefore, our negative discriminant, since our discriminant is negative, therefore this equation has 0 real number solutions, is the way we often say that. No real number solutions. Let's just check this equation out on Desmos. Let's graph the corresponding function y equals that. There's my function, and I can see that I have no x-intercepts. In this next example, I've taken a similar quadratic equation. I've just changed the coefficient on the x from 2 to a constant k. And the question here is to figure out for what values of k will this quadratic equation have 2 solutions. So determining number of solutions we know is related to the discriminant. So we're going to look at b squared minus 4ac. And in our example, we can see that a is 1, b is k, and c is 3. So I'm going to substitute that information into my discriminant to get k squared minus 4ac, and I can see that my discriminant then is k squared minus 12. And we then know that 2 solutions will occur if the discriminant is larger than 0. So to look for where the discriminant is greater than 0, it might be first helpful to look at where the discriminant is 0. All right? And this would be one solution we know. And 0 is equal to k squared minus 12. And the discriminant would be 0 if I solve this equation, if k was plus or minus the square root of 12. Just to show that on our animation, if we make the b coefficient the square root of 12, you can see that we have one solution. The graph is just sitting on the axis, or negative root 12, it's over on the other side. So it stands to reason that if root plus and minus root 12 gives us one solution, a value greater or less than that will give us either 0 solutions or 2 solutions. So how do we figure this out algebraically? I'm going to suggest we put our k values on a number line. So this is k is root 12, k is negative root 12, and this is where we had one solution and one solution. So again, as I said, it stands to reason that more or less than one solution would happen when k is somewhere in between these values. So what I'm going to do is I'm going to take a test value between negative root 12 and root 12, a number for k that's in between negative root 12 and 12. So for example, k equaling 0. And if I put 0 into my discriminant, I'm going to get 0 squared minus 12. I'm going to get a discriminant that is negative. And a negative discriminant means 0 solutions if the value of k is between here and here. Let's try a k value greater than root 12 being 3.46 approximately. So let's try k equals 4, and let's plug 4 into our discriminant. We get 4 squared, 16 minus 12. We would get a discriminant of 4. And a positive discriminant, remember, means we have 2 solutions. And then you could do a similar thing less than negative root 12. Try k equals negative 4. You'd have negative 4 squared is 16 minus 12. Discriminant of 4. A positive discriminant, again meaning solutions, 2 solutions if k is less than that. So to answer the question, we'd have two solutions if our discriminant was positive, and that happens when k is less than negative root 12 or k is greater than positive root 12. And if you want to put root 12 into a simplified radical, which we probably should, it would look like that. So one more time with our animation. If b is root 12, about 3.46, we had one solution, and we're saying if it's more than that, our graph will dip below the x-axis, creating two solutions.